Hello and welcome back. This is Physics with Mr. Granger, and this is video 103. We are going to continue our conversation on how to do the math in physics. So this is the 5 steps, part 2. Step 3 is, what do you want to know? What is the question asking you for? All right, so blah, 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 blah. Last sentence. How far has it been displaced when it is 87 meters above the ocean floor? So here's the question. How far has it been displaced? So the thing that we're looking for is a displacement. So what do we want to know? We want to know the displacement. And we're going to use the math symbol delta y to represent displacement, and we're going to give it a value of, well, we don't know yet because we haven't found it yet. It's what we want to know. But we do know the definition of displacement. We know the definition of displacement says it is a change in position. So what we're looking for is how much did the position of the boat change going from the starting position to the final position. I'm just now seeing that my color coding is a little bit off. I normally use this light green color to refer to both position and displacement. But in this video, I thought it would be helpful if I did final position in this color and change in position in this color. I want to give a more of a precise definition here for displacement. Displacement is the difference between the final position and the initial position. I'm going to take this sentence. Let's bring it out here on its own. Displacement is the difference between the final position and the initial position. Let's color code this like we have. So we were using, that color for displacement, blue or green for final position, and this light green for the initial position. Let's go ahead and rewrite this English sentence here. So I'd call this a sentence formula because it is our formula, our instructions for finding displacement as an English sentence. And I want to rewrite it now as a variable formula. And a variable formula is where I represent each thing with the mathematical variable for it. So for displacement, I'm going to use delta x. For the is, is as in a math symbol is an equal sign. So this says displacement is the difference, the subtraction sign, the difference between the final position and the initial position. The difference between the final position and the initial position. I want to rewrite this formula one more way. I would call this the word formula, because instead of using variables, I'm going to use whole words. I'm going to use the words that the variables represent. I think this helps. Let's get the words. Let's bring them back up here. Okay. And I have displacement is the same as the difference between the final position and the initial position. Here we have the same formula written 3 different ways. The first way we have it written as an English sentence, and then we have it written as some math variables, and here we have it as words. So I would call this the sentence formula, the variable formula, and the word formula. Voila. So how is this relevant to our problem? Well, this gives us the formula that we are going to use to solve the problem. Let's clean this up though a little bit. Give us just a little bit more space. I am just now realizing a mistake. I have been using the x variables here in the formula, and I have been using the y variables here when I've been solving the problem. So I'm just going to take these variables here, and I will add these to the delta y also means displacement. Y sub f also means final position. Y sub 0 also means initial position. Get that there. Let's make a little more space up here. Let's move this down a little bit more. Forgot the I. And then we can use one of these formulas or the other, depending if our problem is happening in the horizontal or vertical direction. Let's just also maybe add a little of this so we know what direction we're talking about when we talk about horizontal. Horizontal is like the horizon. It's the backy forthy direction. And then vertical is the uppy downy direction. I lost my little arrowhead here, so let's get that back. Sorry for the confusion here. Normally when I teach this, I use X because we're usually working with cars in the horizontal direction. But I changed the first example to be a sinking boat to align with our class activity and kind of didn't foresee all the downstream effects or changes I'd have to make. Namely, that I'd have to introduce both versions of this formula at the same time. Both of them mean the same thing. This is final position, this is final position, this is initial position, this is initial position. These are both displacement. So now we're set up to use this version of the formula to solve instead of this X version of the formula. Isolate the unknown variable. What does that mean? These are our variables. This is the one we don't know. That makes it the unknown variable. We want the unknown variable isolated on its own side of the equation. What does that look like? That looks like this right here. This is the variable that we don't know. It is the unknown variable. It is isolated on its own side of the equation. Isolated variable. It is the only variable on that side of the equation. These variables over here, they have other variables around them, so we call these nested variables. Nested variables, they have other variables around them. This text looks too big to me. I think that's better. Since the unknown variable is already isolated, we do not need to do anything in this step, but that will not always be the case, so be careful. Step 5. Do the math and solve. I have the formula, which is the instructions for finding the answer. I'm going to plug the numbers that I have into the formula. I'll make a new line. First we have final position. So we'll plug in 87 meters for final position. My initial position is 139 meters. So I'll put in 139 meters for my initial position. What is it that the formula is telling me to do? It is telling me to subtract. Let's open up our calculator. 87 minus 139, and that will get us negative 52. Why the negative? The negative makes sense because we lost 52 meters of position as we decreased from 139 to 87. To complete our answer, we'll just write it out. The new boat was displaced negative 52 meters when it sank. Those are the 5 steps, and you can use that strategy to solve every single math problem you will encounter.